So this is the first of the series on integration. Specifically what we're looking at is area between curves. So suppose we have a curve or a line such as this, let's say. I'll just move that into shot a bit. Suppose this is one of our curves here, and suppose we have another curve here or another line. So let's say this is f of x, and this other one here is g of x, or vice versa. What we are particularly interested in is the area between the two curves enclosed by the two curves. This area here. Okay, so this will be on the xy axis, let's say. So what we have to do is find the points of intersection, and specifically what we have to do here is find it's a definite integral problem, so find the upper bound there, or the lower bound and the upper bound. And essentially what we're doing is subtracting one evaluation of the definite integral from the other. If you get a negative value, just disregard the sign. That's sort of very arbitrary choices as to what constitutes fx and g of x. Just as a remark, actually, I'll just shade this in blue. This is the definite integral of f of x between a and b, will be this blue area here. Okay, the one I'm shading in blue. But the definite integral from a to b of g of x is the blue area and the green area, which is obviously larger. So splitting the difference, or computing the difference, is how we get the area of the green value of the value of the green area alone. So if you get a negative value, just disregard the sign. It's just like it's arbitrary choice of what you've done here, f of x minus g of x. And just remember to specify units. So essentially what we do here is we just simplify this expression here, f of x minus g of x, and evaluate the resulting definite integral using a and b as the limits. So here's two examples here. The first of our examples is as follows when the page comes up. There we go. So find the area bound by the curve y equals x squared and y equals 2 minus x squared. Just as a sort of quick remark, this is a curve here. It's a quadratic curve. This is also a quadratic curve. The reason I know that is the highest power is 2 in both cases. So we have x to the power of 2 there and x to the power of 2 there. For this curve we'll call g of x, and this curve we will call f of x. Okay. Now, f of x looks a bit like this. The reason we know it looks a bit like this is because it has a negative sign at the highest power. So we don't really know where it is in terms of where the x and y axis is. It doesn't really matter too much. But essentially, anything with a negative sign in front of the highest power should look something like this for quadratic. This is a positive sign, so it would actually have the opposite orientation. So it would actually be downward facing, so it would be down something like this. And again, we don't really need to know exactly where the x and y axis are. So what we're interested in is this shaded area here. But what we have to do here is compute the upper and lower bound of the definite integral, which is sort of say what is a, what is b, what is the point of intersection for both points of intersection, particularly the x-axis, the x value of the point of intersection. So what we do is that f of x equal g of x. Okay, so we have x squared. Well, that's our well, it's actually here I'm doing it in reverse. Minus 2x. So 2x squared, add x squared to both sides, we get x squared equals 2. X squared equals 1, so x equals plus 1 or minus 1. Okay, so that is equal to minus 1, that is equal to plus 1. Okay, so let's just go back to our formula here. F of x minus g of x. So f of x here is 2 minus x squared, and minus g of x minus x squared. The integral from 1, or minus 1 to 1 dx. That's essentially the area we're looking for. This is the area of the shaded area there. So let's compute that. Let's just go down here. So that is equal to from 1 to minus 1 of 2 minus 2x squared dx. That is equal to 2x, we're just integrating it now, minus 2x cubed over 3. And we are evaluating that at 1 and minus 1. Okay, this is a straightforward evaluation problem now, so it's actually quite a simple problem. So that's just actually the first thing to do remark upon is that this is a great time to get your calculator out. So for evaluating this expression here for x equal to 1, which is the upper bound, okay, we would have 2 times 1 is just 2. My x cubed, 1 cubed is just 1, so minus 2/3. Okay, and let's evaluate it for the lower bound. So minus another minus 2x when x equal to minus 1 is just minus 2, and x cubed, that is plus 2 over 3. So just watch all the signs here. Correctly, actually, I'll just rub this plus sign out. Correctly, what we've done here is we have a minus sign and another minus sign, because minus 2 or minus 1 cubed is minus 1. So, and then the 2/3 means we have minus 2/3. But the two minus signs cancel out. Essentially, what I'm sort of saying there is just be careful. All the minus signs can be fit all over the shop, particularly with these problems. Simplifying that becomes a plus now. So simplifying that, we can actually put this over 3. So 6 over 3 minus 2 over 3 plus, I'm just taking out the brackets there, so plus 6 over 3 minus 2 over 3, that is 8 over 3 square units. Okay, so that is the first one. The second one, that's the answer there, 8 over 3 square units, that's the job done. The next one we'll have a look at here is, this is another question on the tutorial sheet. And my machine is jamming up. Bear with me a second. It's gone too far. This is one I've done already. I'm doing the first one again, actually. I messed it up the first time. So now we're this is something similar here. X squared minus 6x plus 5. So let's draw that curve there. It has a plus sign on the highest power of x squared, so it's a downward looking quadratic. X minus 5 is just a sort of a straightforward line. Okay. We don't really need to know where the x-axis is, but we'll just draw it in here just to sort of make sure where you have some sort of idea of what's going on. So we're actually interested in this shaded area here. And again, what we have to do is find out what the upper and lower bound is. So A and B, A and B. So we have to find out what A and B is. We're going to let, this is x minus 5. We're going to let that equal f of x. And we're going to let this equals g of x, the quadratic expression up there. Okay. So it does, like, again, if you were to go f of x minus g of x, or have the opposite, all you would happen there. I've just have an educated guess as to that, the fact that it'll come out as a positive number. But if you just went the opposite, you just get a negative value at the end, and you can just change the sign. So anyway, find the points of intersection. Let f of x equal g of x, and we would have x squared minus 6x plus 5 equals x minus 5. That is equal to x squared minus 7x, subtract x from both sides, and add 5 to both sides plus 10. That's equal to 0. So we have a little quadratic there. Let's factorize it. That is x minus 5, and x minus 2 equals 0. So x is equal to 2 or x is equal to 5. So this is 2 there, and that is 5 there. Okay, so what we're looking for is x minus 5, that's f of x, minus g of x, that is x squared minus 6x plus 5 dx. And let's simplify that. I'll just move this down here so we have more room. That is minus x squared minus 7x minus 10, or plus 7x. Again, watch out for the signs. We have an x there, and we have a minus here, and a minus here. So minus and minus is plus dx. Okay. So that is equal to minus x cubed over 3 plus 7x squared over 2 minus 10x. And we evaluated that at the upper and lower bound, 5 and 2. This one here just requires you to just sort of take your time and be careful at it and just get your calculator out. Mine x cubed is when x is equal to 5, so x cubed is 125. And minus x cubed over 3 is minus 125 over 3. X squared is 25, and so we have 175 over 2. 7 times 25 is 175 over 2, and minus 50. Okay. On the next side we have 2 cubed is 8, so minus 2 cubed over 3 is minus 8 over 3. Okay. X squared is 4. X squared over 2 is 2. So 7 times 2 is plus 14. And finally, minus 10x is just minus 20. So you could essentially just sort of put this into your calculator. I'm just going to break it up into two parts. Minus 25 over 6, just put everything over 6. For example, just minus 250 over 6 plus 300 and multiply that by 3 to get whatever over 6 minus 300 over 6. Essentially minus 25 over 6 plus 26 over 3, or in other words plus 52 over 6. This is simple enough stuff. So plus 52, oops, my pen broke. Plus 52 over, okay, we'll just lay 26 over 3. That'll be 52 over 6. So that works out to be 27 over 6, and that is equal to 4.5 square units. So that's the first two from our tutorial sheet. And there are 2 more of these. I've actually made them already. And so we'll wrap it up there. So that's for parts 1 and 2 of the 6 questions on areas under curves.